Hello and welcome back to 21.1. So we left off on finding the B intersection for C. So here I underlined set B and C. It might be useful to use this Venn diagram to see what is only in set B, only in set C, and what they have in common. So we'll place the numbers in their appropriate setting. Remember, intersection is what they share. So that'll be what's in here. So it might be helpful, since it's empty, to list out set B and set C. 2, 4, 6, 8, and 1, 2, 4, 5, 7, 9. As you can see, I have a 2 in common and a 4, so I'll write 2 and 4. 6 and 8 are only in B, and 1, 5, 7, and 9 are only in C. So what are some numbers that B and C have in common? I'll let you fill that in. Now, what's not in A, again, we'll utilize this graphic. So we have what's in A and what's not in A. What we're going to do is we're going to place the numbers for set A. So we'll list on what's not A. So A is 1, 3, 5, 7, 9. Remember the universal set, I believe, was 1, 2, 3, 4, 5, 6, 7, 8, 9. So essentially we already included the 1, we already included the 3, the 5, the 7, and the 9. That means that what was not in A was 2, 4, 6, 8. So that's essentially what we'll list, I apologize, right here. So all the numbers that are not in A or are in the gray. Okay. Let me go ahead and erase that scribble mark. I apologize. All right, going on. So now we're going to find what is in the middle for both. Pen. So let's place the numbers for A and B. And remember, it's what they both share, essentially what would be in the middle. So let's go ahead and compare. For A would be 1, 3, 5, 7, 9. B would be 2, 4, 6, 8. Hey! They don't have anything in common. There's nothing there. What is a symbol for empty set? I'll give you some options, but I'm not going to write the actual symbol. So is it this? Is it this? Or is it that? Which one of these symbols would I place here to show that it is an empty set? Look back at your notes because I'm not going to tell you the answer. So on to page 10, it states here, for the following represent a sample space in set notation and state how many outcomes there are. So there's two things we have to do. We have to do a sample space and then how many outcomes there are. So let's imagine there's a bag. See, wow, it's on the screen. And we have 3 marbles that are blue, 2 that are red, and 4 that are green. Highlight, underline, do it now. Underline or highlight, hopefully you did one of the two, because we're about to list some stuff. There's about 3 blues, so blue pops up 3 times. There's about 2 reds, reds pop up twice, and 4 greens. There they are. You don't have to color code it on your notes, but there they are. And count up how many words or how many marbles is that? In the sample space. I was thinking how I'm going to write that down. And no, I'm not going to count for you. You are going to do that yourself. All right, so let's say we have a spinner. Let's highlight. And just so you know, we're going to spin this thing twice. So it's a spinner, so it spins and then it lands on one of the numbers. Since we're going to spin it twice, we're going to make a grid. And why didn't I just say the answer was 1, 2, 3, 4, 5? Well, as you can see, am I spinning once or twice? spin it twice. So that means, yes, my number could land on 1, 2, 3, or 4, or 5. But on the second spin, it could also land on 1, 2, 3, 4, or 5. So what we're going to do is we're going to fill out the first row. 1, 2, 3. Notice how the ones are going first, since there's the ones. This is the one row. We're going to pair them up. 2s. And I'll let you finish filling those in. And then feel free to count once you fill this in. It's going to be useful, so make sure you're filling this in. Notice how I'm leaving one of them blank. If you're wondering what's supposed to go in the blank, hint, this is 1, that's 1, 1, 2, 1, 3, 1, 4, 1, 5, and so on and so forth. But take a moment right now and count how many boxes I just asked you to fill in. Hint, I'm bubbling it if you want to highlight or circle it, but go ahead and count how many boxes, or how many possibilities this is. Are there? Oh, sorry about that. So pause and do that now. And unpause. So it says read, explain from your textbook, and complete the following activity. So it says in an event, if an event is impossible, the probability will be blank. If an event is certain or will happen, then the probability will be blank. So notice how we have a couple of things. There's the word impossible. Ooh, the word impossible. Yay. There's the word certain. Oh, there's another. And then there's something called even chance, otherwise known as 50-50. That's because it's a half chance. Again, notice how we can show probability either as a decimal or as a fraction. So I could show this as a 1 out of 6 or 4 out of 5 or just 1 whole or 0. So I kind of gave you some hints. If it's an impossible probability, I wonder what number you put here. And if it's certain probability, I wonder what you'll put here. Hint, hint, look at the screen and go ahead and fill that out, because I'm not going to. We're going on in 3, 2, 1. So again, this is something taken from your textbook. The theoretical probability of a certain event occurring is the number of outcomes in an event out of the total things that could possibly happen in the sample space. So I'm not going to fill these in, but essentially they are shown here of what you should fill on page 10. And unpause. Hopefully you continued on. So we're going to use actually some of the numbers here. It says a bag contains 3 marbles and 2 red marbles and 4. Hey, this is like the problem we had. What's the probability of a blue marble? So let's refer to that picture. How many colors or how many words, how many marbles was that? 9. There were 9 marbles in that bag. How many of them are blue? 3. Now, this is correct. This is the probability, but we can also reduce this fraction. Essentially, think about 1 times what gets you 3, and 3 times what gets you 9. 3. That means we can cancel out that 3, and we can reduce that fraction to 1/3. Like I said, not saying that this is any more correct than the other. This is just the more simplified version. Simplified version of the answer. This is correct, but this is more simplified. Okay? And it's good practice to simplify fractions. On the next one, remember we have that chart. So if you haven't filled it out yet, yes, I guess I'm technically showing you what that chart would look like filled out. But let's refer to that chart to answer. How many possibilities was this? How many boxes did we fill out here in yellow? Unpause. Hopefully you wrote that there are 25 boxes we filled in. What is the probability that we spin at least once on 5? So at least once on 5. Not blue marbles. How many where we have how many possibilities land at least once on 5. And I'll give you a hint. Count it up. And unpause. Hopefully you counted and wrote that 9. Yes, can we reduce it though? I don't think there is, because 9 times what gets you 9? And 25 times what gets you 25? Oh, yeah. Well, I guess that's as good as it gets. Again, not saying that you have to reduce every fraction. Again, this is correct, and actually we couldn't reduce that fraction, so that's fine too. All right, we'll come back on the next video to finish out the rest.